Welcome everyone, and thank you for joining the second day of Bodiless.js AI Edition conference. So we are continuing our journey, and today we are going to reshape the way we build, ship, and think about our software. By the way, yesterday we had two amazing talks, one about Coursera and one about ethical AI. So if for some reason you've missed these talks, rewatch them. They are available on YouTube. And again, since we're talking about YouTube, click like, subscribe buttons, leave some comments. Thank you very much for that. And today, it's super honor to me to welcome our next speaker. So today, it's my pleasure to say that Dennis is with us. Dennis is our chief software engineer, senior vibe coder, autonomous coding agent, orchestrator. Okay, and simply speaking, he's a great human with great sense of humor. And his talk will be all about AI voice agents. So to begin our discussion a bit, right? I know, Dennis, that you've got amazing demos, slides, and whatsoever. Do you mind to tell me just one thing? Have you ever had a chat with someone, I mean like voice chat, and only then, only after some time, you did realize that actually you're talking to AI, not a real person. So what was the thing that made you think that it was AI?
You know, it's a nice question because in reality, I had vice versa situation. One day I got a call and like voice, quite special voice, without any noise in background, said something like, "Oh, if you have 5 minutes, I would appreciate that you." I'm okay. AI. Now tell me. No, I'm a real person. I'm just calling like 100 people. So yeah, from time to time you see like not AI be upgraded to the people level, but
Mhm.
people can downgrade to the AI level when they're doing this not cool stuff when you need to do call to calls to the people
Okay.
with something.
Okay.
Yeah.
Okay. I see, Dennis. I see. Right. So then let's go back to your talk then, and yeah, tell us about how we can make AI agents sounds more human, right? So we cannot distinguish them, right? So the stage is yours, Dennis.
Thank you. Uh, Good. So let me start. For now, during the next half an hour, we are going to talk a bit about the AI voice agents and how to cook them nowadays. I don't want to waste time on the presentation, but Pasha already mentioned everything that is important. I only will add that I like three things in this life: uh, play computer games, create AI agents, and work in EPAM. Uh, Good. Now, I would suggest to start with a short demo. Unfortunately, we cannot also connect a phone line to the translation, to the stream. So I'm going to do it from my phone via this mic. I believe that it will be like possible to you to hear it. If no, put like something in the chat and guys will notify me. Uh, let's do it.
Hello, I'm the election poll bot.
Hello, how are you
Hello,
doing?
hello, I'm the election poll bot. I would like to ask you a few questions to gather your opinion
Sure,
before
let's
the
proceed.
election. Great. Can I ask how old you are?
Yes, I'm 40 years old.
Thank you. Now, could you please tell me which city you live in?
Oh, I'm in the capital of Ukraine.
Got it. You're from Kiev. Lastly, which candidate do you plan to vote for? You can choose between Darth Vader and Mickey Mouse.
It's a hard choice. I believe I'm for the Dark Lord.
Thank you for your response. Here's a summary of your responses. You are 40 years old, live in Kiev, and plan to vote for Dart Waiter. Is that correct?
Yes, sir. Thank you very much. In general, that's it. And during this quite short demo, as you can hear, we can see all the benefits, all the like top possibilities that we can get from voice bots. The main point that like previously when we were working with like decision tree based implementation, it was a bit harder because you need to like either add some additional processing for non expected phrases, or do some I don't know, some classification after it. For now with AI it's much easier. As you can see, I can answer in a non direct way. For example, that I'm living in the capital of Ukraine, that I'm voting for Dark Lord, etc. And for both, for LLM under the hood, it's enough to understand what I'm talking about from the context. Besides that, also important part, and we will talk about it a bit later, that as you can hear, I can interrupt bot. I don't need to listen to, I don't know, as you remember, all times when you need to wait until I say beep and start like talking, pressing some numbers, whatever. So nowadays it's more looks like a real-time, real conversation with a real human. So from my point of view, that's amazing, and that's where we are going. Still, at the beginning of the demo, you can hear that bot was either triggered by some noise, either like don't understand me, whatever. But the good news that again, on the prompt level, we can do some adjustment and cover all these situations that is unpredictable. To be honest, in real world, there are like huge amount of things that could affect your conversation. Now, to understand how all this stuff works under the hood, I would suggest to go forward and start with a global overview on the high level architecture. The good news that there are no any kind of hard like complex parts. We are mostly using some existing well-known technology, and the best part that configuration is also quite simple. On the next slide, we'll go a bit deeply and I will describe how it works under the hood. But now let's start from the high level. The main idea that in the most cases, I even can't imagine the situation when you want to do it by yourself. You're going to utilize some already existing gateway. It could be something, it could be Azure Communication Service, it could be Twilio, it could be similar components provided by ServiceNow, by Genesis, by AWS, by Google Cloud, whatever. So all of them have already implementation of those components, and you don't need to reinvent the wheel. The idea stays the same. The idea to use this gateway as a unified way how to connect all your sources inside. The main point that in the most cases you will not be, okay, not you, maybe your customers will not be satisfied with using only one channel. And from this perspective, you will have phone, you will have web, you will have mobile, whatever. It's open question. Will each channel support two modalities, like text and voice, for example, or it will be text only, or it will be voice only? But the good news that during this time, you can utilize the same gateway for everything. So single connection, everything goes through. The agent itself, in our notation, is just some kind of combination, as always, of prompt tools or whatever. So we're not talking about any kind of execution there. Still, the good news that modern prompting technique gives you quite wide possibilities how to organize it. It could be a flow like step-by-step flow, as in this example that I just showed. Yeah, when we ask first question, ask second question, etc. Or it could be just a free-form task for the model, like for example, okay, listen to customer, figure out what was already provided, and then I don't know, and then collect all the information that were missed. The point is that under the hood, to support all these parts, all these tasks, we need two components. One component is a real-time API, and the second one is implementation of text-to-speech. I especially do not focus on speech to text, because in the most cases we have we don't need to do it manually. Something like 1-2 years ago, still you need to do a custom implementation of Whisper, for example, and this Whisper have to process it, then you get text, grab text, then you go back to LLM. Now we have enough amount of multimodality large language models that could work directly with voice, and the step in the most cases could be just skipped. What we have inside the real-time API, I apologize, it's really quite principal architecture slide, but the main goal is just to highlight what we really need. As I just told, we have this audio input. On the one hand, audio input, it could be text input, depends on the configuration, yeah? But the main point that during the processing it with large language model, we can utilize a couple of things provided by OpenAI from the box. It means that you also can expect in multimodality setup text output. You have from the box text-to-speech inside real time, and of course standard things like tool scoring and context. From all of those, I would suggest to focus on text output and text-to-speech module. In general, for English-speaking bot, you don't need anything else. All your operations could be conducted just by using real-time API, for example, and it will work. If no, okay, there are some modules for other LLMs that also could be utilized, and it will work. The problem is that in the most cases, still, LLM is not a TTS, right? And it means that even if you have some output, like speech output, it can't be compared with professional solutions. When we are talking about professional solutions, we are talking about, first of all, SaaS services like ElevenLabs, for example, Play.ht, Assembly, etc. If you have limited budget, if you are limited with security, for example, okay, in this case, you can use TTS models provided by big cloud providers like Azure or Google, whatever. They have a bit worse, I would say, quality from the professional one, but still it will be better than what you can get from OpenAI, for example. It's one point. Second point, that in all those cases, we'll talk a bit about the tone of voice at the end. But the main point that you have limited voice catalog, unfortunately. During all these operations, that's the most important part of the bot design stage, I would say. You are not expecting to hear, I don't know, old English professor voice somewhere on the support channel, right? On the one hand. On the other hand, you are not expect to, I don't know, to hear something unexpected on sales, for example, voice bot. Yeah, so it's about the tone of voice, it's about the speech, it's about the accent. So a lot of things needs to be kept in consideration to get the smooth UI UX experience with voice. And that's where this limited amount of 6-8 voices, it will not work. You definitely need a professional catalog from where you can choose like something specific for your case, what you really need. But good news that even with current implementation of real time, we have possibility to extract text output. As soon as we can extract text output, it means that we can use some of the external providers that I already mentioned. The only point that be careful. There are, even for ElevenLabs, it's like the most of my experience with them. You have at least 3 models, so you can have always to compare the quality. It's one point. And the second point, just a small life hack from me. When you send text to ElevenLabs, always add this covers as it was I don't know, direct speech from persona. In this case, it will proceed with emotions much better. Also, like my personal opinion, it's a bit harder. You never should wait for the full output. Use streaming. With streaming, we get into another problem, because if you are going to stream it like token by token, by one token, text-to-speech model will not have enough information to proceed with proper intonation, with proper pronunciation, etc., because like model just don't see the context. On the other hand, if you wait for the full text, yes, it will be like the maximal quality on the one hand, but on the other hand, you will expect a big delay, because like no LLM can do it in one step, so it's always like time consuming operation. Just to summarize all of this stuff, so the ideal strategy is to use some meaningful pieces, like separated by, I don't know, by comma, separated by dot, whatever, but small piece of sentence could be sent and could be processed. In this case, you will get the, let's say, the ideal balance in between quality and speed. But what if, in some reason, I don't know, because security, because something else, you can't implement, you can't like use real-time API on your project? It's quite fun and quite easy answer. You can do it by yourself. As you can see, there are no any like very complex components except one, and it's voice advanced detection. In general, like all the parts of real time, it's available in different forms on the market. You can choose like what kind of model, what kind of TTS STT you want to use, but the most important part will be about voice detection. The main idea that in the most cases you don't want to detect voice. In the most cases you want to detect silence. And as you understand, in real life, there are not so big amount of places. In reality, there are no places where you can stay in a full silent when you can't hear anything. There are always some noise. Depends on the level. Like like in this, I don't remember, James Bond spy movies, when they extract information about like, oh, he's eating popcorn, he's near the cinema. So in real life that works in the same way. In real life, it's even a bit harder because if like all those bad guys at least try to stay silent, clients and customers in the most cases know. So they will call you from airport, they will call you from, I don't know, from the car, they will call you from a bus station, whatever. From this point of view, what is the most complex and the most hard part of all this voice bot implementation? Why so? You have just a couple of parameters. In reality, like you have two opportunities. You can start from the low level using some, I don't know, some of your favorite audio processing libraries and do it by yourself. It's not so hard if we are talking about minimal implementation. Just like add some detection of silence active signal, and it will be enough. But it will be enough only for like your home tests while you are staying in a silent room or silent place. When we are talking about real places, it's a bit harder because first and the most important maybe on this slide is the energy threshold. It's if it's fixed level, it could work, but it will work not on in all situations. What is this? For example, even now in my mic, there are going a lot of noise. And the point is that all of them, for example, I don't know, from the street, they presented, you see here, like even on this recording, but they have a quite low level. And by using this like stabilization level, we can just cut them off. We can ignore them. That's fine. The problem is that in the most cases, it's not so good as in my apartment. And we need to keep into consideration that situation could change. To cover the change in situation, you need to understand like what is the real voice and what is the noise that could be produced periodically, but is some random event around you. To do it, you need to understand also like what environment your client is, and here that's where this dynamic energy threshold could help you. So the main idea that yes, if situation change, you can classify it, you can understand what's going on, and adapt your levels based on it. Of course, also you can play with everything else, like including frame, lens, frame shift, hand on, whatever. But the main idea stays the same. Somehow to understand, is it a voice or it's a noise? From the box, you can use a couple of solutions that's already on the available on the market. I don't want to name them because, every day I will get something new. But in the most cases, some things will be already available inside the devices. For example, if we are talking about, I don't know, some Apple phones in your AirPods, you already have some voice isolation functionality. In Teams, you have some voice isolation functionality, etc. We are going to talk about voice isolation in a short, like just one slide after. But first, let's start from a sample rates. The sample rates is also kind of the most important part of all the stuff, just because all the different channels will have different sample rates. And when we are talking about phone line, it's maybe the easiest, because in phone line you have something like oh my god, how it called, ULAV, ALAV formats. That is like has quite small sample rate. It means that you don't need to do something for additional isolation, uh, just because you will not hear it. It's like in God we trust. If you can hear at least voice of the customer, that's fine. When we are going to the higher levels, like I don't know, good quality MP3 that is available in web browser, for example, or via a custom application on mobile, that's much harder, because here you had much more information and it's harder to analyze. On the one hand, it's very important to analyze this parameter for each bot, just because first you can save some money and time on the generation, because for phone line, for example, you don't need like full amount of functionality and generate your answer with a higher sample rate. You can use lower and it will be faster and cheaper. For like good channels, yes, it will take longer, it will be harder, so and it will cost more. Up to you, depends on your setup, how it works, how it's implemented, what is your goal. And but just keep in mind that all those parameters should be taken into consideration. And my favorite one is voice isolation part. We already start talking about it on the what slide, and let's proceed there. So in general, as I already mentioned, there are not several, like a lot of solutions for what implementation on the market. The main balance and the main pain point that you are going to get with it is a balance between speed and quality. The point that you can get quite good result from a quality perspective, like it can isolate almost everything. But as soon as we are talking about real-time scenarios, it means that it will cost us some time. So speed will be affected. And in the most cases, it's not possible to use everything that you want to use. So you are going to decrease, for example, quality of isolation, but you will get more speed. There are no like some best practice or good answer about it. It fully depends again on the area, on your clients, on your channel, on sample rating of your channel, of course. But you always have to find this balance in between. Do I want to hear a user in, I don't know, hear user correctly, I mean in 93% of situations, or 80 will be enough, and like I always can just ask to call me, contact me from a bit more silent place. It's up to you and it's up to business. Besides that, also we have several other possibilities how to use it. For now, let's start with hardware maybe. In the most cases, hardware, it's quite rare situation. For example, this point about multi microphone setup, yes, it works for, I don't know, for some conferences, for some big presentations, for professional like meeting rooms, but it's not obvious. And to be honest, it can't be like a target audience for the bot in the most cases. Of course, if you are doing like some kind of virtual host for, I don't know, for conference, that could be your case. But in the most cases, no, it's impossible. The same, for thresholding noises. Yes, you can do it, but see the first comment about balance between speed and quality. You never can do like everything that you want. But the good news that a lot of such things could be addressed on the LLM level. How it works? I got new case like just literally yesterday. One of the colleagues asked, like, I have a problem. I'm working on a voice solution for one of our customers, and we have a problem with recognition for pronunciation of some like specific term for this organization. What we can do, how we can fine tune like whisper, fine tune real time, whatever. The problem is that in some situations you don't need to fix it. There are huge amount of like accents. Again, my favorite point for this speech, voice on environment, etc. So in some cases, it could be addressed via the LLM. You always can tell the agent, like, man, all the input that you are going to have will be from transcription. It means that you can expect that some words will be incorrect, something could go as wrong, etc. Please take it into consideration and fix based on the context. And I would say that in, I don't know, 70-80% of situations, it works. If the mistake is not critical, if you miss only like 1-2 words, that's fine. It will work. If you are talking about the situation with special terms, the same. You can provide, you can describe to the model what kind of words, what kind of dictionary you expected, and it can proceed. In the most cases, it can proceed on a very, very, very good level. But there are some situations when, for example, this only one word is critical. And to address it, we can use another technique. It's quite old technique, I'm always using it by my own during the last at least 30 years. It's ask to rephrase. If from the prompt perspective, LLM sees that this part is really critical, it's really needed, we cannot make a correct decision without a clear understanding what we're talking about, it's better to add this instruction to ask user to rephrase. Like, okay. Or another option, I believe everyone who is non-native speaker in some language, you also should know this technique. And by the way, it was even presented on the demo at the beginning. So the idea is to recap. If you remember, at the end of our conversation during the demo with the agent, he starts to recap and confirm information like you are 40 years old, you are living in Kiev, you are going to vote for Dark Vader. That's also like very good option, because in this case you can give user to fix only the part that is really mismatch with correct information. It's one point. And second point, it's like additional validation for you that you hear and understand, not you like agent, hear and understand it correctly. From this point of view, I would suggest to move to the last slide for today, and it's tone of voice. I promised at the beginning that we are going to say a couple of words about it at the end. So, tone of voice. From my point of view, most valuable part of any bot, because the point is that when you are using classical text implementation, it's a bit easier, because text could be like read it and that's it. When we are talking about any kind of complex modern agents that utilize, for example, video, audio, etc., it's much closer to the human communication. And in human communication, as you understand, everything makes sense, like intonation, pronunciation, I don't know, emotions, if we are talking about something, etc. If I try to sell you with something like, "Oh wow, do you want to buy this pen?" You will not believe me. So I should be like very active person, like provide you a lot of information about this pen, etc. And in the most cases, based on some predefined scenarios that we can get from the life around us, it will be even okay. We can expect some quick speech like, "Oh, Mister, you are interested in it. That's only for you." Blah 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 blah, and so on. So all those things needs to be involved in the voice agent design, and the main point there that it needs to be taken into consideration even before you start. You need to understand how your agent is going to talk, what speed, what intonation, what age, what gender, etc. Taking all of this, in reality, you are going to not only align with like your brand book recommended by company, but in reality, even using only voice, you are going to create some virtual creature, virtual person that you can see, but you can hear it. And at the end, you are going to like communicate with such kind of bots as a real person. Uh, yeah, I think that's it. So good luck, everyone. That's me. That's everything that I want to say today. And I believe I can pass back to Pavel. Maybe we have some questions.
Yeah, thank you, Dennis, for this amazing talk. Really, a lot of details, and I found a lot of good and new stuff. Thank you very much for that. Regarding the comments, though, it seems that our audience is still digesting these materials that you've provided so far, and we have literally zero questions so far. But I have to remind you guys that if you have some questions later on, do not hesitate to drop a comment, and Dennis will be super happy to answer them all. But actually, I do have one question to you. So you've mentioned a lot of things, right? And most likely the evolution, right, of voice agents is in place as well. So do you think that not this year, but maybe next year, we will see the next big evolution step and we will have no possibility to distinguish whether we're talking to the human or to the AI?
To be honest, if you have bad channel, the sampling rate that I told about a couple of minutes ago, even now you will not be able to separate AI and not AI.
Okay.
With good prompt, with normal work on virtual person, last slide, tone of voice, if everything like prepared as it should be, if your avatar don't want to be identified, it's another big question because of laws you have to add this like identification part. Yeah, if someone asks, "Are you AI?" you should or okay, not you, avatar should answer that yes. But in the most cases, again, it's with low level quality audio like phone line, you will not be able to identify whom it is.
Okay. So I understood that, though my question was more like general thing, right? So right now we are mentioning that with some specific, right, case like phone call, right?
Mhm.
You may have like troubles to distinguish person with AI. Though if you are chatting like in Teams, right, or if you have some Zoom call, something like that, you can definitely say that, okay, that's AI, that's not a real person. So when we are going to see this like next big step evolution where you will definitely have no chance to identify. I mean, like not speaking about the phone, not speaking about the low quality audio, but like good sound quality.
I don't know, and I believe nobody don't know. For now, the main point that okay, how you can detect AI based on speed? No, based on the quality of answer. No. The good answer to your question may be this hype around LinkedIn, where everyone start to check not pronunciation, how it called, like commas, dots, all this long dices. I lose the word, but you get what I mean.
Yeah.
So, as you understand, if we detect AI based on the correctness of the language, we are quite close. So let's wait like a couple of years, and AI signatures will be visible only for either like some special people, either for other AI.
Okay, so advice for AI: if you are listening to us, make mistakes, do do some stupid sentences, make some mistakes in general.
You look better than the real person.
Yeah, and then you'll try to mimic us. Okay, right. Thank you, Dennis. So that's it, I assume, for this talk. Thank you very much, guys who are watching us or who are rewatching us in the recording. Drop your comments if you have some questions to Dennis. Again, it was the second day of our Borderless GS AI Week edition. Tomorrow we have amazing talk. The next day we have amazing talks as well. And on Friday we will have amazing talks as well. So stay tuned. Happy coding. And yeah, see you soon. Bye bye.